Hey, Dive students, who's enjoying the day? I think we're going to have a good time here. All right, so it's snowing. How's everybody doing? All right, we're going to talk about some geologic time for you. Things are good. Hope you're staying warm. The other day, what'd you do? You did the geologic dating. You found something interesting that happened on your birthday, right? If we compress the entire age of the Earth into a year. Look, we're going to go and we're going to start really talking about what's happening on Earth and some of the length of time and history that we're talking about on Earth. But today is about the how. Today's about the how. So let's look. Rocks. Not the how. I'm just talking here. It's how we know. The rocks record everything. That's weird. The rocks record geological events. They record changing life forms. Of all these things are in the past. Okay. It's interesting. It's there. It's in the rocks. How in the world does a rock record anything? It's just a rock. Well, we're going to find out. So the other problem with this, though, is erosion. Because erosion can permanently erase some of history. The thing's just gone. It can erase some of that. And not just erosion, subduction. If you've got two plates and one goes under the other, the second plate is now gone. And we never knew where it was. Before Pangea, there were other continents, but they're gone. We don't have any way to know what it used to be. All right. Earth is much older than people previously realized. Now, when I say people, I do mean history of people, history of mankind. Going back, Earth's old, like way before, because we all think of ourselves. We all think of ourselves and our parents and our grandparents and our great-grandparents, and we get history, and we think of people as history. Earth's way beyond that, and nobody knew that for a long time, all right? The interior and the surface of Earth have constantly been changed by all these geologic processes. Okay, one of the first attempts to really age the Earth, Archbishop Ussry. Okay, he's the first one. Let's not make it. He's the first one. He's the guy who said, "Hey, yeah, Earth started in 4004 BC." He's the one who came up with that date, and he did it in the mid-1500s. It's not accurate, but that was the first shot. That was the first stab that people had. So if he said 4004 BC, and he got down to the year, that's pretty good. But no, he's not even close. Okay, the late 1700s, you get a Scottish physicist, James Hutton. And he comes along and he starts one of these ideas, and he starts uniformitarianism. Uniformitarianism. What in the world? Okay, what that says is the physical, chemical, biological changes that are happening right now are the same physical, chemical, and biological changes that have always happened. That the laws of physics that work today used to work all the way back when. So if we see erosion today, that's how erosion used to work on the ancient Earth. And there's no other way about it. So uniformitarianism. That's a mouthful. Okay. Change is really, really, really slow. How in the world? Change is just ridiculously slow because it's geologic. I can see erosion, but in my lifetime, a riverbank might erode a handful of feet. It doesn't look like anything is going to happen. It's not going to create a mountain. Like outside of volcanoes, earthquakes, and the little bit of erosion we see, there's not a lot of evidence that the Earth is changing. It's a rock. It doesn't look like it moves, but it changes all the time. It's just really slow. All right, we got 5 things here. We're going to talk about all of these things are methods to tell us about relative dating. No, not that kind. The different kind of relative dating. Okay, relative dating says we're not worried about the actual age of a specific rock yet. All I care about is which rock is younger, this rock set of rocks or this set of rocks. I don't care if it's 4,000 and 5,000 or 4 million and 5 million. Right now, I just want to know which one is younger, because if I can put things in order, then later we can start talking about ages and dates. So right now, relative dating just means aging, putting things in order first to last, and the aging comes later. So it's just a sequence, okay? That started late 1800s, early 1900s. All right, several attempts were made to do that. Okay. First thing, we got a Danish guy, Nicholas Steno. Wow. Next three things. All right, these are all stenos. Three things. Law of superposition. Law of superposition is real simple. In an undeformed sequence of sedimentary rocks, right? The oldest ones are on bottom. Each bed is laid on top of the other one. What's that mean? Undeformed, that's important. Sedimentary, that's important. So if you've got a river, and every fall the river slows down, and when it slows down, it starts dropping mud, right? And in the spring it picks back up, and in the fall it drops mud. So the layer of this fall's mud is on top. Last year's mud's on bottom, and last year's mud's on bottom, and the layer of rocks on bottom can't be newer than what you put on top. You stack the rocks up and you build them up. That just kind of makes sense. That's the law of superposition. Undeformed and sedimentary. When you have a whole bunch of sedimentary layers, the old one's on bottom. That's it. All right. It does also apply to lava flows and volcanic ash, but mostly sedimentary rock. All right. Also, steno, the principle of originally horizontal or original horizontally. If it's sedimentary rock, it was kind of at the bottom of a pond, lake, ocean, whatever. It's all going to settle out and everything's going to be flat. So originally it was flat. And if you find rock that's later bent up in layers that are twisted, then it was changed. Originally, everything is laid down horizontally. So you can find things that have changed. Okay. By the way, 1669, that's when these were. These are the Danish guy, Steno. All right. Principle of cross-cutting. Last one of Stenos. If you got a whole bunch of layers of rock and you have a fault or an inclusion, remember magma's coming up in there, the fault breaks and cracks. Guess what? If the fault is newer than the layer that it breaks through. So if I've got 7 layers and the bottom 4 are all cracked with the fault is younger than the bottom 4, but then the top 3 layers are unbroken. They were put down after the fault, but the fault happened after the bottom 4, right? So you can use that to order all of those things. All right, so that's cross-cutting relationships. Inclusions. Okay, inclusions. Remember, this was back when inclusions, this ball of magma that pushes up and moves and lifts a landform. It's really big. All right, igneous rock comes up. Okay, here's the thing. This is a hard one. All right, so you get the inclusion. You bring up this igneous rock, and then later there's some erosion. And you erode the sediments off, and then you got down to the igneous rock, and you erode some of this igneous rock. You erode the igneous rock, and then later you redeposit sediments on top of it. Okay? So now if we're looking layer, if you have sediment and you have igneous rock broken bits in it, that the igneous rock inclusion is older than the sediment that it's in, because the sediment was deposited on top of it. You can't use the law of the superposition because they have been disturbed. They're not undeformed. There was a deformation, okay? Let's see. Unconformities. Unconformities are breaks in the rock record, okay? So you can have all this stuff. So you've got deposition, you're depositing stuff, and then all of a sudden it stops for a while. And then it erodes, and then later you have redepositing. You're like, how in the world does that happen? So you are low. You are depositing stuff. You're depositing stuff out of a river, depositing stuff. So it's build. Somehow maybe it gets pushed up. The river moves. Something gets pushed up, and now you're eroding stuff away. And then later the whole place sinks down, and you get more deposits coming back in. As the height of the seas change or the height of the land changes, you get these broken bits. So unconformities are breaks in that. All right. Those are some of the big processes. That is today's video. There were no pictures. There is no stuff. The vocabulary. Today was just vocabulary. It's getting cold. I can't talk straight. stay warm, stay safe. I'll have the rest of this with activities later in the week. Have a